Hello, Precalculus student. This video is for chapter 5.4, right triangle trigonometry. And we define the sixth function with a right triangle when angles can be anything from 0 to 90 degree. So we have this SOHCAHTOA definition and also the reciprocal of the sine, cosine, and tangent for sixth function. And because of that, we also have well, actually not because of that. And because of Pythagorean theorem, we have two special triangle, and we figure that we can use SOHCAHTOA to actually generate sine 45, sine, cosine, tangent 45, sine, cosine, and tangent of 30, sine, cosine, tangent of 60 using SOHCAHTOA by just looking at there's two special triangle. Now, with these numbers or with the two triangle, you can say that these two triangles actually can help you to find the nine trig functions, an exact value. So we want to find missing side of a special triangle. Why is it special? Because the one of the angles is a right triangle, of course, and also and one of the acute angle is 30. So this is a 30-60 right triangle. So we remember for a 30-60 right triangle, if I redraw it, if this is 30 degree, I would have 1, 2, or 3, right? 1A. Well, actually, we just say 1. So this is one of the one side length of the 30-60 triangle. So we can look at it and then do with SOHCAHTOA. So even if you misplace your unit circle, you forgot your unit circle, if you can draw this triangle if you remember SOHCAHTOA, you can do sine, cosine, tangent of 30, sine, cosine, tangent of 60. Okay, so this is how you do it. So with that, we can use it to find the missing side length of a special triangle. So for example, we cannot find A and C together. We would have to use the given length 7. So if I want to find A, I would use 7 and A, and I have the 30 degree. So for 30 degrees, this is the opposite, and this is the adjacent. So opposite, adjacent, TOA. So I would write a tangent ratio. Tangent 30 is equal to 7 over A. But tangent 30 in my pre-written triangle is what? Is 1 over root 3. So we can actually solve this by saying, okay, so 1 times 7 is 7. Root 3 times 7, so you can solve it this way, or you can actually solve it because that's tangent 30, also tangent 30. Sometimes we write as root 3 over 3, or you can just write 1 over root 3. They're the same thing. And then we can change it into a equation. So 7 times root 3 equal to A. Or you can do proportion. 1 times 7, that's multiple way, times 7. And then would be times 7. So A is 7 with 3. What about C? So to find C, I would have 7, which is opposite. C is the hypotenuse, and opposite hypotenuse is saw, right? Saw. So we would say sine 30 is equal to opposite 7 over C. But sine 30 from the triangle that we have, or from whatever that we have written, we know it is 1/2. So then we equate them. We would say, okay, 7 over C is equal to 1/2. How do I find C? C would be equal to 14, right? Because 1 times 7 is 7. 2 times 7, that would be C equal to 14. So this is how we solve any triangle that is 30-60, because we remember this, or we remember this table in the table. So whatever that you want, you can write this out in a table. You can just draw a triangle and then do SOHCAHTOA to generate out The next things we're going to talk about is cofunction identities. So it is very obvious that in a right triangle, you have two angles that are less than 90 degree. So relative to angle A, this would be opposite. And this is adjacent, right? This is not adjacent. This is a hypotenuse. So your sine alpha would be opposite over adjacent, but relative to angle B, this side used to be opposite, now become adjacent. So for cosine B, this would be this side that we have over H. So they're actually the same thing. So if I name them as A, B, C, right? Don't name it as O. So sine alpha would be A over C, but cosine B is also A over C, right? And then sine beta would be B over C. Cosine alpha would be also B over C because that would be cosine alpha's adjacent, this adjacent of cosine alpha. So we have this special cofunction identity that is, but what is alpha and beta related? Alpha is equal to 90 degree or pi over 2 minus beta, and beta is 90 degree minus alpha. So we have this special relationship between if I have cosine t, that is equal to sine of the other angle in a right triangle, which is pi over 2 minus t. Sine t would be cosine of pi over 2 minus t. And if you look at the definition of tangent, you see that tangent and cotangent also has this cofunction relationship. Cotangent equal to cotangent t equal to tangent pi over 2 minus t. Secant and cosecant also have the same relationship. And that's actually the reason why we call them sine and cosine, because this is called cofunction identities. So in a nutshell, so if I say, okay, sine 40 degree is equal to what? Sine 40 degree would equal to cosine of 50. So if you switch it to the complementary of 40, they are equal. So we can actually look at decimal to figure it out. I think I'm going to use the decimal scientific calculator. Use degree, right? Sine 40 degree, okay, cosine 50 degree. You can see that they're exactly the same, sine 40. What can we think? Sine 16, what do you think it is equal to? It's equal to sine 90 minus 16. I don't even know what it is, 0.9612. So they're exactly the same. So if you want to switch your function value from sine to cosine, you can just change your angle to 90 degree minus the same angle. And the same for tangent, cotangent, secant, cosecant. So for example, if I have sine t equal to 5 over 12, what is cosine pi over 2 minus t? It's exactly the same because of cofunction identity. So we will say cosine pi over 2 minus t actually is equal to sine t. They're complementary, and their sine and cosine are exactly the same. So equal to 5 over 12. Okay. If sine pi over 6, everybody knows is 1/2. What is cosine pi over 3 using this? Well, actually, pi over 2 minus pi over 6 is equal to 3 pi over 6 minus pi over 6, which is 2 pi over 6, and it's actually pi over 3. So they doesn't look like they are supplementary, but they are they're complementary, but they are complementary, meaning they add to 90 degree or pi over 2. So sine pi over 6 is equal to 1/2 and is also equal to cosine pi over 3. And that explains why in the unit circle, you know, if you have pi, this is pi over 6 and this is pi over 3, they are actually complementary. So you would have over 3 over 2, 1/2, and then for the pi over 3, so this is pi over 6, and this one is pi over 3. The two numbers are 1/2 or 3 over 2, and that is the reason, because this is cosine of pi over 6 and is equal to sine of pi over 6, sine of pi over 3. Okay. The next part is all word problems. So we can use SOHCAHTOA to find a lot of missing sides of a right triangle. We will find missing angles in, I think, in chapter 6, maybe. Yeah, when we do inverse function. But for now, we just use sine and cosine to find missing sides. So if some generic question, so if someone draw a right triangle, remember has to be all right triangle. SOHCAHTOA only refer to right triangle. We'll solve some missing side in a complex right triangle, or two right triangles stick together. First, I have two sides missing, A missing, C missing. I have one angle and 10. I want to solve side A and also side C. So it doesn't matter which one you want to solve first. You can solve A first or you can solve C first. But remember, do not use the rounded number or the approximate number to solve for another side unless that's the only way. So if I want to solve for A first, so the only one I can use is 10 and 62. So I have two sides, one is missing, and then one known angle. So how are these two sides related to the angle? So this is the opposite of 62, and this is the adjacent of 62 because the hypotenuse is opposite to the right triangle, to the right angle. So it is not. So this look like a slanting side, but it's not hypotenuse. It's bounding, or it make up the right triangle. So the one that is close to it is adjacent. So this is A. This one is O. So what is OA? Is TOA, right? SOHCAHTOA, TOA. So that means I use tangent. Tangent 62 would equal to opposite O over A. A is the missing. This is equal to 10 over A. So I multiply A on both sides. So I have A 62 equal to 10. So A would equal to 10 over tangent 62. Put in the calculator. 10. We remember to check that it is a degree. Degree is clicked 18.8. So this is rounded. Okay. So I'm going to solve for C now. So for C, I do not use A to do it. I would still use 10, 62, and also C. So relative to 62, C is hypotenuse. So OH, right? What is OH? Is saw, right? Saw, OH. So I would use sine of 62 to relate the two sides. Sine of 62 would be O is 10, H is C. So multiply C on both sides, sine 62C equal to 10. So C is 10 over sine 62. And round it to one decimal or whatever that they want. So I would just change it to sine. Oh, is it divide? Oh no, earlier I did something wrong. I should be a divide. Divide tangent 62. Gosh, 5.3. That doesn't make sense. 16 is too long. So this one is wrong. 5.3. Let's say 5.3. That makes sense. It's 10, 5.3. And C would be 10 divided by sine 62. I'll just override this. Yeah, it's dividing. 11.3. Around 11.3. Which is a unit length. The second one, do I have enough time? Maybe I'll do it in the next video. So this is to find x. Now x is a side of a triangle, but is it a right triangle? So let's see. I have 39, I have 63. If I add this together, 63 plus 39, they are 102, right? So this side is not a right triangle. And actually, I do not know any of this side. So to find x, you would have to find them one by one. I do have two right triangle. One is this one. The other one is on the right-hand side. So I would call this x1 and this is x2. So x is x1 plus x2. But it would be in the next video.